Hello there, good morning everybody, and welcome to the Metaverse. I'm glad you found it at this early hour on the second floor for the 309 room. But we all made it, and I very much appreciate your attendance. Of course, the Metaverse is the virtual, volumetric, 3D, collaborative environment that we'll all live in someday in the future. I don't know exactly when, but if anybody knows, it's probably some of our speakers over the next hour. My name is Pete Luday. I'm a technologist working on immersive media based in San Francisco. And I'm also part of the team that's created a new organization to make sure that the Metaverse actually happens. It's called the IDEA, the Immersive Digital Experiences Alliance. So we wanted to give you a little bit of background about the technology and the plans to be able to bring this strong vision into fruition and to tell you how you could be part of this as well, because we think it's very much of a collaborative effort, and the spirit of the founders of this new organization is to really have an open source, collaborative exchange of information, and that's what we're very much looking forward to. So over the next hour, I'll be giving you just a brief introduction into the topics we're discussing and why IDEA was formed, and then we'll get into the meat of the matter. We'll have a speaker reminding us all about light field imaging, which is one of the enabling technologies that's been around for 100 years, but is only now practical. And so you'll hear about light field image capture and light field image display and transmission, and even distribution over broadband networks. And we'll have time for questions. So let's, with that, move on a bit. This is sort of a concept, the holodeck, that we all talk about when we're envisioning what the future might look like. So think of it from today, you have a little rectangle screen on the wall of your living room or in your hand on the mobile device, or for those that flew in, that little screen in the front seat in front of you, if the person kicking back into your knees. And that will change. In the future, we have the ability to expand the image to something much larger, much more lifelike. We're talking volumetric, not just stereoscopic. And all these things are possible. So the vision of the IDEA group is to create a practical suite of interchange standards. This technology exists, but how to transfer files, how to archive and distribute them is not so easy. We want to make sure it's display agnostic, because this is an evolving field. There's many types of displays ranging from AR, VR to stereoscopic up into full light field displays. Of course, sound is really important. I know this is a graphics special interest group, but we believe that the audio portion of it is equally important in terms of the overall ecosystem. We also need to make sure it's practical in terms of taking these huge volumetric files and being able to fit them over available commercial networks, and the ability to leverage new media-aware networks that become available. So all of this is part of the charter for the Immersive Digital Experiences Alliance, immersivemedia.com, sorry, immersiveexperiences.com. Alliance.com. It's written down, so I don't have to remember it on one cup of coffee. And you'll hear much more about that. So first of all, the goal here is to create this immersive technology media format, ITMF. And this would be ability to transmit over a media-aware network, or there may be display specific renderers, but it's agnostic to the display. So on the left, we're showing you could look into a full light field display, creating a volumetric space. You could also look at multi-planar head-mounted devices, VR, AR devices, stereoscopic displays, which are not popular in the home, but still in movie theaters, and of course, legacy. So we want to be able to do that conversion to all of these. And we have a couple of purposes for forming the alliance based on the last 3 or 4 years of discussions about like-minded people wanting to make something happen. So one is to create this suite of royalty-free technical specifications. And these would define the interoperability interfaces and exchange, support end-to-end conveyance of these immersive models. It's also very important to gather marketplace information and technical requirements, both from the creative community and the practical network and technology communities, because it really is a team effort. And so we need to get all these together in terms of being able to have these discussions. And towards that end, we're developing relationships with people like the American Society of Cinematographers, as well as the Visual Effects Society, the Society of Motion Picture and Television Engineers, and others. Thirdly, we want to facilitate interoperability testing. It's only as good as what you're able to demonstrate, and we want to be able to host and demonstrate such demos, our first one being a plan now for this fall, which is kind of a very rudimentary proof of concept, and we want to build it from there. But I think that having these sandboxes in which we could all work together to test and confirm the functionalities is going to be very important. And a large portion of it is education, because this is a lot of new technology. There's a lot of very smart people involved, but from different corners of it, and there's this cross-fertilization of ideas so that technologists understand more about the goals of the creative community, the network operators understand more about the trade-offs between latency and quality and image, and the whole immersive environment could emerge by having these discussions and education back and forth. And towards that end, we are planning a all-day seminar based here in Los Angeles later this fall. We haven't got the date pinned down yet, but we're looking for some exciting venues and materials. And finally, an exchange of information, a forum to be able to exchange these viewpoints. So this is very much like many industry alliances. We want to be very focused on the creation of this future of immersive imaging. So again, the opportunities are that we could create a display agnostic interchange format. So I could have one format that is able to be rendered on multiple devices, ultra realistic imaging, and you'll hear a little bit more about what we mean by being able to extend it far beyond what's available today, and different kinds of content. So we see this eventually as a home entertainment format that works very well for scripted drama, music performances, but also education and certainly out-of-home entertainment. So we'll see where it goes from a commercial standpoint, but we don't want to preclude any of those. The approach of this immersive technology media format, ITMF, is that we could take not just computer graphics, but also photographically captured material from light field arrays, volumetric data that might be captured through LiDAR, time of flight, other sources, and of course in the future a strong emphasis on artificial intelligence, machine learning in conjunction with the computational photography. So we don't know exactly where all these things are going to go, but we're keeping very much in mind that that's our goal, to be able to preserve all of those pathways. And it does require, as I mentioned, a whole series of different viewpoints. I've been involved in a standards community for standards development organizations for many years, and sometimes you get a bunch of really smart experts in a room, but nobody's really telling them what is necessary from a emerging media or creative or practical deployment standpoint. So we're trying to avoid that pitfall by having a very open discussion between all segments of the industry. For the result of this will be a royalty-free and open source specification. We want it to be built on established technologies, ones that we don't have to reinvent from scratch, ones that are being used today for being the interchange computer graphics files, and to be able to build on those. We don't want to be constrained by raster-based image compression formats that are out there today. Those have served us well since the early 1990s, like MPEG-1, MPEG-2, and beyond. However, we feel that the light fields and the immersive imaging require some new approaches, and we don't want to have those constraints. It needs to be extensible because things are going to be invented in the future, and it has to be based on real-life priorities and requirements. So we don't want to be pie in the sky on this. We are a membership organization. Here's a list of some of the founders representing the cable industry, because they're looking for ways to fill those pipes and be able to optimize networks in order to build the future of immersive entertainment technology, and companies that are involved in the premier technologies that create light fields and immersive imaging. Many other companies we're in discussions with now to become members, including some of the people you see there, movie studios, content producers, sports networks, et cetera, and the technology folks from consumer. We have one tier of membership. It's intended for corporations at either $2,500 or $10,000 per year, which is typical for these sort of alliances, and that's the only funding that comes in. There's an initial board, won't go into all those details. And we are looking at the possibility of having a associate type membership for people that are not part of a company, but want to kind of stay informed about what's going on. So if that's of interest to you, let us know, and maybe we'll think about bringing in a way to build this community, even if it's not with large companies. There's a couple of specifications that are currently in process. There's a scene graph specification, which defines a volumetric space that is then streamed and transmitted. And then there's a container format requirement specifications. Both of these are being worked upon in working groups within the committee almost on a weekly basis, and we expect to have those released this fall as a version 1. And there's no doubt that there's a lot more work that will go into this over the years, but we want to set a foundation. There's some of the goals we're at. Here we are at SIGGRAPH. We have a couple of other industry events that we'll be participating with, the release of the specs, and that's really what our focus is. If you're considering your company becoming a member, we think there's a lot of benefits to be able to be part of this discussion, to have a seat at the table, to be able to contribute, to be able to learn what's going on, and to be able to be a key part of building the future of this immersive technology. So that's it. There's the URL. And with that, let's get into some more of the technical aspects of this. And next up is Mr. Ryan Dam. He's the founder and CEO of a company called Visby in San Francisco that's been inventing light field capture technology. And he's going to tell us a little bit about what that means. Take it away, Ryan.
Let's see. Figure out where that is there. Let me find my presentation here. Thank you, Pete. It's a very nice overview of what we're trying to do here. Hey, there we are. As Pete mentioned, my name is Ryan Dam. I'm the CEO and founder of Visby. My goal in the next 10 minutes, because I think they give me the hook in 10 minutes, is to just give you a very brief overview of light fields primarily for live action and the kinds of content we want to be describing in the ITMF spec. As Pete also mentioned, our focus at Visby is on live action content capture and coding. So we're kind of the voice of live action within ITMF. Just so I know kind of how deep to go here, has a mind of its own. How many here are fairly familiar with light fields? That's a good number. I apologize. This is going to be fairly introductory. Anyone who's kind of a rank amateur, doesn't know what's going on here? All right. I'll try to stride in the middle here, but if you start playing Candy Crush, I won't feel bad. So at a high level, I kind of want to introduce the idea of why we're trying to do what we're doing here, holographic coding, and then cover what I think are 3 broad categories of content that we want to try to code for. Roughly volumetric video, which I think is actually fairly mature, ray tracing, which is kind of more O-Toys bag, and then light fields as a catch-all. The motivation here is that this wide range of new displays are functionally holographic, right? You move around, you want to see the image update in a way that matches your perspective, whether it's a head-mounted display or like a light field panel, like what Light Field Labs is working on. The common thread there is you need a holographic standard, a holographic image. It would be nice if a single file format or streaming spec could serve all of these devices and also all these different kind of content types. So that's kind of motivating what we're working on here. In terms of the state of content, these to me are the 3 gross categories, right? Volumetric video, which I would argue kind of borrows from fairly mature video game technology. Ray tracing, which is a little bit more of its DNA and its roots in the visual effects industry. And then light fields, which in my mind are an extension of the kinds of techniques we applied to 2D video coding to this like larger holographic problem. And I can go into a little more detail about what that means and why. Now, ultimately, what we're trying to do, both in IDEA, I think, and long-term in the industry at large, is to find a way to build a codec that looks like what 2D video did for 2D screens, right? So it's got to eventually serve all these displays. It's got to be pretty robust. But it should be encoding light rays, not pixels. Significantly. There should also be a record and playback function, right? So technology that really only works for synthetic content is not necessarily of broad interest, though you also have to support synthetic content. And my mental model for this is you want to take a signal that you care about in the real world. You want to be able to capture it, compress it, and encode it, and then have it decompressed and played back at the end. This is all pretty rudimentary, but I think those are table stakes for a real codec. Okay, let me quickly build up why I think the signal processing approach is relevant. In sort of traditional 2D photography, right, you can think of the image that you're capturing as analogous to an image we would see in our eyes, right, which is essentially just a 2D mapping of light rays. Every single pixel in a 2D video codec represents some small ray bundle that passed through a camera, right? The holographic analog here is if you've got all these light rays bouncing off of a scene and you want to be able to serve any perspective of that scene, well, you've just got a lot more light rays you have to capture and support, right? If you can capture those light rays, recreate them on the fly, you functionally have a light field or holographic image. The raw signal we should be interested in is this 4D raster of light rays. This, to me, is ultimately what this codec is trying to describe. Okay? So I know everyone gets excited about the specific data types and polygons and interpolation kernels. I think we need to think about this impossible 4D raster as the sort of ground truth. Unfortunately, it's completely inaccessible. And I think this is the source of a lot of the coding challenges in this space, is that a dense 4D raster of light rays is, one, not accessible to any real-world application, and two, represents a massive, massive, massive amount of data. An uncompressed single frame of reasonable resolution light field data would ring in the petabyte scale. Okay, so that's clearly out of range of even tomorrow's networks and tomorrow's hardware. At the same time, capturing that petabyte scale image is functionally impossible because you can't overlap cameras nearly densely enough. This is one of our early prototype arrays. We got those darn GoPros as close as we could. We're still undersampling by like 3 or 4 orders of magnitude relative to a dense raster, okay? So that, to me, is the fundamental technical challenge you have to overcome in both your capture and your coding standards. Okay, so let's talk about what these various coding approaches do with this problem. Functionally, to me, volumetric and ray trace technology starts from a similar point of wanting to understand the shape of the scene. It does very different things with them, of course, but volumetric video, being functionally video game tech, takes a typically polygon model, could be point clouds, and when you try to serve a ray out of that potential 4D raster of light rays, you ray cast into the scene and you query the surface and you come back with an RGB value. Pretty straightforward, right? This has been working for a very long time. It's fairly mature. Getting to that polygon model and RGB texture involves a fair amount of sophistication, right? Computer vision, build your models, and so on. But once you have that, the tech is fairly mature and does work well. If you look at some of the existing volumetric solutions that are out there, they work, they're good, and they're fairly effective. I think it's a little bit limited in the kinds of things it can express, but it is really an important part of the mix. Ray tracing represents a better way to do it, where you, again, ray cast into the scene, you query the surface, but then you actually bounce rays around. I'll talk a little bit more about that, although that's really much more Jules' game. Light fields, and this is again, VISB's focus, is a very different approach, where you try to understand the signal and recreate it as it was in reality. Okay, so a little more detail, we talked about this. Raycast, there's your texture, there's your color. For ray tracing, of course, you don't stop there. You don't have a single texture. You actually want to bounce those light rays around and try to understand how light actually would move through the scene. This is a very robust, very high-level way of essentially simulating physics as best you can, right? So you got some model for how light moves around. You try to simulate what those light rays would actually do and come back with a pretty realistic-looking value. I think anywhere else in this conference, you can probably see how good that is getting. It's really, really compelling. It is also a little bit different from a traditional video playback. This is really more the light field game. Set up a whole bunch of cameras, have a huge data footprint, and try to do something with all that resulting data. The supposed benefit of trying to do light field coding is you don't have to have an explicit model for either the shape of the scene or your physics model, right? All you're doing is grabbing a 4D raster of rays and then playing it back. That's actually a total lie. And when you get into practical coding and actually real-world light fields, it never really quite works that way. But it's at least the compelling jumping-off point. That's the vicious lie. Here's why it's a vicious lie, okay? So if you imagine a trajectory of cameras, right? And you think about all the light rays across that 4D surface. There's a lot of light rays that you really care about that you're not actually capturing. Only the ones that go through the aperture of the lens are actually registered on a sensor anywhere. So you essentially have this massive undersampling problem. If the top line is the signal you care about, which is an amazing high-fidelity squiggle I made in PowerPoint, and then you think about the sample points that are the camera apertures, if you don't actually have those intervening light rays, the reconstructing the ones you've missed is a fairly hard problem. It's essentially undersampled and sort of an ill-posed reconstruction problem. That reconstruction problem, if you do it naively, will lead to all sorts of problems. The most prominent of which would be edge doubling. You'll see a lot of smearing, and ultimately really, really weird artifacts. So if you ever do a really naive, like light field coder, decoder, you'll oftentimes see things like this. The central problem is that interpolation, you don't really know how to draw that light ray you missed. The fix is essentially to borrow from volumetric and ray tracing techniques where you actually have an explicit polygon model 4 point clouds. And when you have a light ray that you care about that you didn't directly sample, you then go query the model and say, okay, if this light ray came from this surface, what are some nearby light rays that look similar, and then interpolate from there. This is old. This dates back to 1996. And if you look at the work that's being done on light fields today in a practical way, it is mostly this technique. There are several other techniques that are outside the scope of this. Again, they're going to give me the hook in a few minutes here. If you're interested about that, go ahead and email me. I can elaborate a bit. But functionally, this works today, and this is the most mature form of light field coding. By doing this, you recover a few things. You do get good detail. You do get view-dependent lighting effects. You will miss out on some things you didn't sample. In fact, if you've got something really sparkly, there are light rays that fell between cameras you just really can't reconstruct, at least not in a forward way, right? Sparkle that fell between cameras is forever gone unless you want to simulate it somehow. I should say this technique does work very well. So our company has built an image-based rendering codec. It works extremely well. We can start with a big array of cameras. We can compress it down to a fairly small file size. It can be very soon will be streamed across a network, and then can be played back on a client device with today's hardware. It works well. I think this is going to be an important part of the future. That is not to say it's the only way to do it, but it's a jumping off point. So that's a little Light Fields 101. I hope those of you that were new to it got a little bit. Hopefully those of you that are fairly experienced in light fields understand it at least a little bit better, or you got a high score on Candy Crush. Once again, my name's Ryan. My company is Visby. My email address should be up there. Feel free to email me if you want a copy of the deck or if you want to ask me any further questions. And I think Jules is going to now take it here and talk a little bit about other things.
Yep.
Fantastic.
Thank you, man.
Cheers.
I'm going to do it from the table. Just want to make sure this is on. Great. Let's make sure. There we go. So, quick show of hands. How many people are familiar with Otoy and Octane and the things that we do? Oh, great. Well, in that case, some of this might be old, but there's a lot of value for those that aren't familiar with everything we do and discussing our experiences building the technology that we think is a fundamental part of getting to here, the Star Trek holodeck. And as Ryan so eloquently put, there's a lot of different pieces to this problem. I think ultimately these displays are going to be powered by technology like Light Field Labs panels. And what we want to do is talk about our experience in the industry with the different pieces of technology that we think are fundamental to that. Our goal as a company is to democratize the tools needed to create and publish this content. So having an open standard through IDEA is fundamental to that. I spent years in MPEG. I'm also part of the GLTF working group. And I believe that sort of a standard a little bit above those is necessary for all this to work. You know, our pipeline has been focused really on 3 different parts. Capture through LightStage, which many of you may know. It's been around for about 10 years. Octane Render is our basically our physics simulator. It really is an unbiased, spectrally correct path tracer on the GPU. And we've also experimented with publishing content through Orbex Media Player, which premiered on the Oculus Gear VR and Samsung Internet. On the capture side, if you're not familiar with LightStage, it's a giant dome with many lights, few cameras, and it gives you back really awesome digital doubles. Octane has been used for production rendering. You're seeing this in Marvel movies now and in Emmy Award-winning television shows. It's really fast. It's almost instantaneous, and it's a stepping stone towards providing a robust runtime renderer. We've been working on pieces of GPU rendering and ray tracing for about 10 years now. And sort of at the end of this decade, we're now at the point where things like ray tracing hardware, AI ASICs for denoising, and truly connecting this to holographic displays start to become really important and interesting. Orbex is a format that we created along the way with Octane to export and interchange assets between all the different plugins that we have supported in Octane today. There's about 26 of them. Yesterday, we released plugins for Unreal for free, Blender 2.8. And what's cool about this is that Orbex initially was just created with other open source subformats in mind. But today, you can actually take any single scene that you have in any of these tools, spit out an Orbex package file, and import it into another tool or plugin. And this is the basis, so we're contributing Orbex as an open source format to IDEA to help build a standard around that. And Orbex itself, there are 2 pieces. There's a container, which is like a zip file, but it's designed to store things like the Leanbic and other things that are tricky to put inside a normal zip or a zip-based container format. And there is something like HTML. It's an XML-based node graph that doesn't just have materials, it has everything you need to actually fully render any scene. And it is open source. It's built on a lot of open specs. OpenVDB, for example, for volumes. Open shader language, huge part of the specification. We've actually been talking to Larry Gritz at Sony ImageWorks, who's created open shader language. We're working on adding extensions that other renderers can adopt for things like cameras and implicit surfaces. And we've also been trying to bring these technologies into the most popular tools and making at least a reference renderer for OrbX free. For example, in Unity, about 3 years ago, we announced this free integration. Yesterday, we launched this in Unreal, which has been great, also free. And in ITMF, as we sort of take OrbX and we turn this into something that the industry could adopt and that others can help us improve, we're looking at, again, a subset of existing formats that we found are very mature. Leanbic, for example, for animated geometry, is pretty bulletproof. EXR, same thing for textures. Udym for texture tiles. And everything that we're doing outside of some of these, in the scene graph right now is XML. OpenVDB is, again, rock solid. Open shader language I just described was a great open shader format. We think it's very portable. We're seeing almost every renderer adopt it. And then for scripting, yes, Python's very popular, but Lua is very easy to sandbox. And ultimately, that's sort of what we're beginning with. We're also working on things that are artist-friendly. We've done a lot of, we have a lot of experience with what artists want, and they definitely want layered materials. That's now just introduced in the new Unreal Engine. It's also built into the spec, so you can create sort of any BRDF that you want, layering these things on top of each other. A little bit simpler than closures in OSL, but we intend to support those as well. And we also want to support everything that you see in production rendering, for example, random walk, which is in Arnold, even Blender. It's in the spec as well. It's fundamental for skin and how light transport works in objects. Hair, again, is something that's based sort of on the Disney paper, again, adopted in many different renderers. And we're also looking to extend things into everything that you can render with physically correct rendering, including fluorescence, polarization. These are things that are fundamental to truly recreating and also capturing reality. And also non-photorealistic rendering through OSL shaders is something the spec will cover, as well as totally procedural volumes that can be defined in open shader language. So in the case of open shader language, again, procedural textures are really an important part of it. There's no better compression than writing bits of shader code and having that provide your textures, your volumes, your shapes. And we experimented with that last SIGGRAPH. We announced, here's a spec for taking open shader language and using that to create procedural geometry. And we're doing the same again for doing displacements and custom, volume shaders. And all these things are really well described in the spec that we're, the 1.0 spec that Pete was mentioning we're going to be putting out in the fall. And I think that, between a lot of these pieces, even ray tracing into the scene graph is going to come with very small footprints for the sizes of files that you're sending down the pipeline. And we're also looking at many other third-party formats that are really important to ITMF and OrbX. So OpenColor.io is an obvious one for color, standard support. USD and Hydra is obviously going to get a lot of attention at this year's SIGGRAPH. Obviously, you're seeing a lot of attention from side effects with Solaris. USD will be everywhere, and we think it's about 90% there to replacing Leanbic. And Hydra, as an interface and API, which we've experimented with, is probably a great way to get any renderer to support a spec like this. And we're also looking at MDL from NVIDIA. And as I said, we're also part of the GLTF PBR Next working group spec. We see GLTF as a flattened format that we could output to from OrbX or from ITMF's mezzanine spec. And we're also talking to Autodesk about adopting the Arnold standard surface, which they open sourced in March. I want to talk a little bit about some of the work that we've done actually putting these technologies into practice. Beyond Lightspeed, we've also worked with Facebook on a camera that now is being adopted by Red. They're building something called the Red Manifold. It's I consider a light field camera. It's got 15 lenses. We're part of the process that takes the camera data, spits out OrbX files from the cloud that can then be loaded back into After Effects, Nuke, Unity. This is from one of Facebook's SIGGRAPH booths recently. And the idea is that you can take something like Nuke and import an OrbX file that's captured from these cameras, blend these things together, and you already have pipelines that work today with the pieces that we're now turning into industry standards. And we obviously want more members to help us get this just right. Along with that work, obviously Lightstage has been used for a lot of visual effects work. We've also been working with game engines to get this data into a format that can be adopted in real time. For those that haven't seen anything around Lightstage, it captures more than just points, it captures normals, it captures basically the full reflectance function. So this is not using any shaders. It's being lit by this light probe, but artists don't have to do anything. Lightstage captures all the different properties. It is basically every single pixel can get a depth, normal, and reflectance field function, and you can see it captures insane amounts of detail. And we've tried to extend that to make Lightstage capture really, really inexpensive. This is just using 2 point gray cameras. We can take that data and bring it back into Unreal or Unity, relight it, and that fundamentally, is a problem for live action capture that we want to try to make real time and solve. So that's why getting Lightstage quality into real-time capture is very important. You do need less cameras, you need more lights, but there's many shortcuts that we're exploring for that. And also having Orbex and ITMF as a standard will help us allow us to store things that that can be captured from the real world, whether it's objects or textures or even reflectance properties of something like metal. And that's really important. If you're going to re-render something that's a surface, as Ryan was saying, you can interpolate it or you can maybe synthesize it. And if you know the index of refraction and the roughness, you can actually do that in ray tracing. And we're starting to apply these techniques for real-world capture. So this is a scene done for an Oculus contest years back in our software stack. And the artist did a lot of photogrammetry work and created normal maps and ended up with a scene like this that looks awesome from a real-world environment. We want to simplify that and make that really easy through an open source spec that any system can adopt. There's also, of course, brute force light field capture. This is work that we had done a few years back with thousands of views, and of course you get really perfect specular highlights and the rest. It's very dense. Probably not exactly the way we want to capture things, but the spec that we want to support would allow for this kind of data as well as what Ryan's describing. So it's not just synthetic content, it's also raw data and raw rays from the real world that we want to be able to bring into this pipeline. And again, our work with early work with Facebook and Red and other vendors on just building this this early light field camera system was very helpful. And we've also been working on how to get this into players. So again, our work with Oculus and Facebook was really interesting. A couple years back, we announced Orbex Media Player. We worked with John Carmack on this, and it ended up going into Samsung Internet, Oculus Photos, Oculus Social, and it allowed you to package flatten Orbex media files, kind of what we were talking about with GLTF, and embed these 3D 3DOF scenes that you could then load from a link or a URL. And it was sort of our first test case for how to publish something that could actually have a full open source specification behind it and work on various devices agnostically. And really beyond that, we also started to work on how to encode and compress flattened light field renders out of the pipeline. And this is some of the early tests we've done there, starting with planar light field compression and rendering. This is obviously volumetric, navigable light fields. And these are about 40 megabytes per cube. Each cube is another frame temporally. You can load that from disk or you can stream that from a server. In this case, we're running the server on the cloud. We're streaming that to a phone with AR tracking. And I think the next step beyond that is to stream down the reflectance properties and make this perfectly usable in AR. So this is actually obviously picking up the real-world lighting from the scene as it's rendering. And we're going to be showing more of that in our SIGGRAPH booth in our talks this week. But ultimately, you want to be able to have a format that is able to be viewed from any viewpoint and also be relit in the real world from any viewpoint, and more importantly, work on future holographic displays. And that leads us to our announcement last year with Lightfield Lab on how we're going to bridge the work that we've been doing at Otoy with their display technology, which is fundamentally awesome. I mean, I think, correct me if I'm wrong, but John, but it's roughly about a gigapixel per square foot, something along those lines. If you're going to drive that at 60 frames a second with ray tracing, you need a fundamentally new approach to how this could work. But you also need a content pipeline that people can start adopting today and working with to get all this stuff to happen. So at our SIGGRAPH booth, if you want to see the simulator that we built to actually test how our content and how Orbex and ITMF and all the work we're doing actually could work on the LFL displays, we built a simple setup with Vive tracking on a cap and stereo shutter glasses, and you can actually see the data sort of beamformed into your eyes, projected onto a surface, and it actually looks surprisingly pretty good. One of the very first scenes that we tried on John's display was this one, and I keep talking about how we've done A/B testing. I've seen that coat hanger and that door come off of that light field display a few inches, and it is unbelievable. There's absolutely nothing I've seen like that, and so for me, that was my true first holographic experience, and that's why we're so motivated to build all the pieces, all the tools, all the pipeline elements that are needed so that people that are creating content today, just like when you're filming in color, will have the ability for this to work on the holographic display panels of the future. And so really building the pieces for an open metaverse, it just philosophically for us is so important. We've worked with companies like Mozilla. Brandon Ike, who now actually created Mozilla and Firefox and JavaScript, is working on Brave. I've always had a passion for open source, open standards, and IDEA is really designed to help make that happen for this kind of content in this future ecosystem. And we're very excited to bring on more members and to work with the industry to make that happen in in the next year and the next decades beyond, hopefully. So thank you very much.
I think so.
Press the red button.
Sorry?
Red button.
Hey guys, I'm DJ. I lead an immersive group for Spectrum, Charter Communications, and I represent, the network architecture work group, which works closely with the media format work group and the other work groups within IDEA. And so the topic of my presentation today is, what is the role of cable in delivering immersive? We have this fundamental assumption around networks. But I wanted to address that a little further, right? So what I'm trying to show you here is that essentially immersive creates all these demands on the delivery system of immersive, on the delivery system that actually do not exist today. They're starting to come together. So for example, if you consider 2D video streaming, that's a non-interactive application. All your content is available a priori. It's a totally different system than a system in which content is delivered on the fly, where you have to engage compute, right? And then when you think about AR, VR, light fields, and beyond, you have all of those demands, but just by a factor of maybe 100x or something, So don't hold me to that, though. But the point is that we believe that networks will need to engage in order to be able to democratize immersive experiences. And the reason why I say that is immersive is expensive. It's not accessible, not quite there for the vast majority of people. And if the networks engage in the right way, then it can be made much more easily accessible to people at large. And so at the bottom, I've just listed, what kind of bandwidths we kind of talk about today when you, sign up with a service provider. You think about a bunch of Netflix streams that are running, and that's about it. 30 frames per second seems almost standard, although we're moving to 60. But when you start thinking about things like cloud gaming, that's where, it's an example of where compute is engaged in the cloud. And, with the higher frame rates, you need to engage much more bandwidth. Now you need latency that's of the order of human perception, so 50 to 100 milliseconds, so on and so forth. And then with AR and VR, it gets much more stringent when it comes to latency. If you want 6DoF full viewport experiences, you're looking at much more bandwidth as well. To Jules and Ryan's point on how much you need to compress in order to be able to encode light rays, right? So a long time back, John Gage from Sun Microsystem had said, the network is a computer. I guess we all kind of see the evolution happening where the network is the computer again through cloudification. The only thing is that we need to probably take a few more steps for that to happen for immersive, right? So, the first step, the multi-step evolution, the first step of which has already started happening, which is that, GPUs exist in the cloud today. You can deliver fairly high quality of experiences with, cloud GPUs, and companies like Blade Shadow, Liquid Sky, Parsec, a bunch of others have attempted this, and it's been largely successful, so I encourage you to try some of these experiences. The second step of this evolution has to be around computing in order to serve some of these ultra-low latency, motion to photon latency kind of experiences. You need to push computing closer to the consumers, and that is sort of the domain of edge computing that many of you may have either been engaged with or heard of, right? So, but that computing is going to come closer to the consumer, and then finally the displays, whether they're head-mounted, whether they're light field, whether they're anything in between, will continue to demand more and more from the network, and the network will continue to evolve in order to meet those demands. So, essentially delivering streaming immersive experiences of the future, democratized immersive experiences of the future, will be a careful balance of compute, latency, and bandwidth. So what does the IDEA network architecture work group do is, we are trying to figure out that balance. We are trying to put together our ideas at this point, our specifications at this point, that will hopefully lead to reference implementations down the road on, how the right balance is struck in order to develop that, to deliver that high quality of experience. So just presenting some brief evidentiary work of, how we're looking at the network architecture work group. Essentially, the idea is this, today you have end-to-end flow optimization in video streaming. The network is not necessarily engaged other than offering up bandwidth without guarantees largely, right? And in future, in order to be able to meet a certain quality of experience, you might need to engage other things in the network. And that's really the idea of what a media-aware network needs to look like. So, there could be other media processing engines, for example, compute, where you could do partial rendering or rendering here, rendering there, so strike that right balance based on resources and quality of experience in order to ultimately deliver to the consumer a high experience, right? And so I guess this is my last slide, but really at this point I'd just say, as a call to action to you guys, to try and engage with IDEA either through memberships or other ways that Pete described. And we welcome more and more people joining IDEA and participating in potentially reference implementation of the network architecture spec. Thanks, guys.
Thank you, DJ. And we are all birds of a feather here, so we want to have time for some quick Q&A, some questions and opinions and exchange. I wanted to invite one other person up to the stage, and that's John Carafin, founder and CEO of Lightfield Lab Incorporated in San Jose, and a longtime veteran of both computer graphics and fascinating optical and light field imaging. Various roles. So to remind you who we have, Jules Lobrock from Otoy is the expert on all things rendering exchange graphics. We have John from Lightfield Lab to talk about new display technologies that actually make this real. Ryan from Visby to talk about cameras, and DJ from Charter Communications to talk about distribution. If you have any questions, raise your hands. Meantime, I have a few. In terms of time frame, what should people expect in terms of implementation on when we might start to see light fields used for out-of-home entertainment, for in-home, for other applications? Is this 10 years away, 10 months away? What do we think? Opinions?
I mean, I think it's ready right. It's ready right now. You'll see out-of-home entertainment first. It's not ready to stream over a network. You might see the occasional tiny experience that people download, out of Steam or the Oculus Store or something. But I'd say that within a few years, it's going to start to grow pretty quickly.
Any dissenting viewpoints on that? How about interchange standards? Maybe Jules, you want to talk about the best way, the opportunities and challenges for exchanging imaging that's recorded as light fields?
Yeah, I mean, I feel like we've, you know, one of the challenges that we're facing, at least in the part of the work that we're doing in the media working group, is thinking about a standard for a mezzanine format. Obviously, if you go back to the video coding standards of yesteryear, you start with a raw set of pixels that's typically, hopefully, uncompressed in some cases. And what's the uncompressed version of a scene look like? What is that target even for cameras to sort of register to? And so there is a lot of open questions. You have a lot of industry specifications that are nearly there. USD people think, oh, that's a full scene graph. It's missing certain things. It's hard to get volumetric support going in there. It doesn't quite have a full shader description. And so the work that we need to see happen is for that to sort of be cohesively put together so that you have an entire rendering stack that can be portable between different tools, different players, different compression schemes, and ultimately different devices. And that is still yet to be done, but hopefully some of the work we're doing in IDEA will help push the industry forward in that respect.
So there's still work to do.
Yeah.
Which is a good thing. Yeah, Jim in the back.
Yeah, Jim Hellman from Movie Labs. So I see that the need for mezzanine format is, is really, it's obvious it's something that's challenging for all the 3D applications that are being developed today. But I'm wondering, what's your thinking on whether and when there'll actually be like a consumer distribution format, a package that would play the same way that a movie does. And we've had 3D experiences for a couple decades, and they've all traditionally been games that have been developed, coded. They use libraries and tool sets, but there's never been like a playable format that works cross-platform, that delivers great performance on all the different hardware instances. I'm just wondering, what's the thought about moving from a mezzanine type format to actually a consumer distribution package? Is that something that's going to happen?
Yeah, I'll fill that one. I mean, it's very much going to happen. In fact, the slides that I was showing back in 2016, where we showed all that stuff inside of Oculus's ecosystem, Samsung Internet, it was literally taking the mezzanine format and flattening that down to their device. It was baking everything down to the 3DOF experience. Some of the work we're doing now with the GLTF working group is to take GLTF and target that as another layer of a compressed, flattened version of the mezzanine format. Ultimately, though, with enough computing power, the mezzanine format may be very small, and with enough compute, you can just render the whole thing live. But having these layers that exist today to target these other devices, including 6DOF devices like the Oculus Quest, things like GLTF and compression that goes along with that is still an interesting target. So there definitely is already a lot of work that's being done around how to compress something like the proposed mezzanine format that we're working on and get that into different device endpoints. Very possible. We've done a lot of work in that regard, and we're going to do a lot more, I think, with an idea. But yeah, that's something that's fundamental to the entire effort that we're doing here.
And DJ, you want to add? Okay, go ahead, Jim.
Do you think that package will include all of the interactivity, or will it still basically be a platform-specific game application that then uses this format for all of its graphics?
It'll include game interactivity. So part of why we included things like Lua and other scriptable elements in the spec is so that you can target it like you could a web page with WebAssembly and WebGL. We've embedded the entire Unity engine inside of the Orbex media package and stream that down to the to the Gear VR, and it was running. That what you guys saw running in a texture was actually a full Unity sandbox experience, very similar to how Unity and Unreal can target HTML5. We can do the same thing for interactive experiences, and they just need to interact with the scene graph. So you can create custom scriptable elements and use existing tools for that. So that is how we would be able to get full interactivity from the most popular authoring tools inside of this spec pretty early on.
And DJ, any comment?
Yeah, I'll just add that a lot of what you're asking actually depends on where the compute power could lie. Would you separate sort of the game logic from the actual scene, and in what way would you do that, right? So I think that's primarily the purpose of us trying to engage early so as to be able to help it define some of those things, right? And have generally flexible model based on what the topology of a network would look like.
Thank you. I think we had a question in front.
Hi, I'm a pipeline engineer in the animation field. So yeah, I've been sitting through the BG Pro, the pipeline conference. So these formats started in the film industry, and now it's good to see how real time and film technology is kind of collaborating and also fixing the drawbacks.
Yeah.
Because film is not real time, right? So do you think down the line there will be a cross pollination of ideas back into, say, OpenUSD?
Absolutely. I'm putting all our best ideas from IDEA into the GLTF working group as well, because I want GLTF to evolve as a format. I want every single format that we touch through IDEA to take any of the good pieces and add to that. Same thing with open shader language. Olympics kind of baked literally and done, so USD is an area where we want to work with Pixar and others to help make sure that really works well. And when we, Disney actually invested in Otoy in 2016, and we got to talk to the Pixar guys about USD, and it was very early. It crashed a lot. You could do cyclical curves that would crash the whole thing. So we were like, when you guys polish this, when it's mature, this would be amazing. It could replace FBX and Olympic and others, and it's very close now. But there's still missing pieces. There's still some smoothing to do. And we hope that ultimately all the things that we're doing here just get adopted in the sub-formats or even in other specs. But it is something that I think still needs to be done. And we haven't seen others really working on these pieces, and especially all the other parts that interconnect with it for delivery and capture. But yeah, it's exciting to see these things converge.
And just to finish, like having the royalty-free reference implementation, I think will really help.
100%, yeah.
Yeah, good. Yeah, question here?
Yeah, Mark Wendell from HBO. I went to the Augmented World Expo in Santa Clara a couple months ago, and one of the things I was really kind of surprised by was how small the footprint was there of the entertainment and gaming industry relative to industry, driving augmented reality, medical, factory, training, military, and so forth. And it seems like IDEA, with what you've discussed so far, really is focused on consumer-facing entertainment, education, and so forth. I'd be concerned that there'd be a fragmentation when there's an opportunity for combining what I'm sure are a ton of efforts going on in, to us maybe the less interesting, but space of industrial applications for immersive experiences. So could you address maybe if there's some attempt to cross some of those spaces?
I can fill that one. Do you mind if I just grab that?
Jump in.
So out of those 26 plugins that we're talking about supporting, about 8 of them are Autodesk, Inventor, Revit, AutoCAD even. So, Autodesk is actually an investor in our company. They're our first large investor, and we built a huge amount of our stack, not just for the media and entertainment space, but we have a lot of users that are doing medical imaging and use the path tracer to do, volumetric rendering of CT scans. So all of that is sort of incorporated in this. Obviously, it's not as sexy as film and television stuff, but it's all there. So I agree with you. It's a huge part of the space.
Let me just piggyback on that and kind of give a meta answer to that question, right? Which is that IDEA is really focused on finding solutions that are going to work, and we're very Big Tent, right? So if there's technology that arises out of industrial work, it will find its way into what the work is being done at IDEA right now. And in practice, the specification that comes out in the fall will be just the first version of it. And in fact, now is a good time for people who are working on technologies they want to see reflected in the industry to get involved, put their voice in there, and the best technology will end up rising to the top.
And I might just add that I think that the medical, scientific, geoexploratory industries have been well represented in terms of making their own needs known and whatnot. Not as much in the entertainment industry. It's still very nascent. I think there's a lot of creative applications that we're still exploring how those need to be used. So we want to make sure that that viewpoint also has a seat at the table to be able to make sure we're building a format that works for all of these. Did you have a comment?
I think you kind of jumped in and covered a lot of it, but it's interesting to hear that, and I think a lot of the feedback that you're providing is based upon where is the actual revenue opportunity for AR/VR today, of course. And you have to also look at what is the processing requirement for a lot of the enterprise type applications where you can support that more easily with the headsets and the technologies out there, whereas what we're talking about, it's not nearly as easily supported. We're talking about bandwidth and resolutions and interactivity that just fundamentally can't be achieved. And that's one of the main tenets, one of the main goals for everything we're looking to be able to produce is provide that vector representation for the data that allows you to get into entertainment and realistically bring it into every device in every home. So it's not an intentional exclusion. I think you're seeing more of what's possible with technology today versus what we're looking to achieve.
I think I saw a question in the back. Please.
Two-part question here for Tower Studio. In terms of costing, because I remember when Hallelujah got presented a couple of years ago, it was quite in the millions. And obviously, the biggest fear that I have as a small creative studio, in which we have to develop our own stuff, because things like mocap right now, where Intel and Microsoft have these amazing studios, yet I could charge £50,000 for 1 minute, which then immediately puts it away from the true creatives, with all due respect, and ends up in the hands of people that have never experimented with this, and end up seeing it as a new thing that they can do. And I think and I understand there's a whole lot of bandwidth in terms of what has to come in, and obviously the technology, but I think what are your thoughts about how can we help for this kind of technology to be explored by younger generations and by creators that are truly trying to work around it and can actually understand the technology better than those that are sometimes being brought in and paid to pick on?
So good news, it's getting cheaper really quickly. I think accessibility is going to be really important. This technology, if it is strictly the domain of super high-end productions, it's not really going to matter, and it certainly won't become a distribution format. So we're all hyper aware of that. So that's where it's headed. The way people were wiring together 360 rigs, 5-6 years ago, I think we're going to have people wiring together light field rigs within a couple of years. The technology is getting good enough. It's going to migrate out of these high-end, purpose-built studio and stages into the hands of more independent creators. So I'd say sit tight. If you want to get involved earlier to kind of see the technologies before it comes around the bend, I think IDEA is a very good forum for that. You'll see some of these technologies before they migrate down, and be able to get your hands a little bit dirty with them. But if this is going to succeed, we need something on the order of 5,000 hours plus of content. It's not going to happen at $1 million a minute production budgets.
And thank you for that good perspective on that.
I mean, just to dovetail off of that, I think if you look at the very first fully digital films that were ever produced, those were extraordinarily expensive with the highest end of the highest end type cameras, and they were alpha-based technologies that didn't work 100% of the time. So you look today, now you've got it on every phone, you got it on your TV, even microwaves have cameras now, it's crazy. So it's the same kind of a transition. What we're looking to do is make sure that we're protecting the integrity of the data that will get to the end device to make sure that there is a way to have a truly compelling experience, make it an open standard for everybody to be contributing to. So the things that, to answer your exact question of how can you help, it's really making sure that we're doing it right. We're producing the types of formats, the types of things that enable you to create more content more easily.
Good. John, while you got the mic there, maybe you could talk a little bit about light field displays. Now, many people that became familiar with light fields became familiar with the ability to do things like render them with refocusing during post-production. So you could take a photograph and with a narrow depth of field and refocus it later when it's reviewed on a piece of paper or a planar surface. But new light field technology allows you to reproduce that entire depth perception or that environment. Tell us a little bit about what that experience is like and how light field displays work.
How much time do I have?
90 seconds.
Oh boy. So I'll do the elevator pitch version of that. So you heard a lot of information, very well covered by the other panelists here, in terms of what is the difference between 2D and light field and what is the reflectance function, everything about that. So think of a true holographic display as being the ability to have your eye freely focus in space. Your eye becomes now that main lens from an otherwise planoptic system. And the difference between, and Jules alluded to this, the difference between seeing a real object projected in space versus some kind of an illusion representation like VRA or just stereoscopic is exceedingly different. When you get to a certain point of scale and density, you can no longer distinguish the real from the synthetic, and that's everything that we've set out to achieve. The way to think about the technology that's light field is it is for every viewer without any head tracking, without any other accessory that has to be physically part of the body or something else, some other peripheral that you need to provide to the user. You're able to then have that truly immersive experience. But to do that and to achieve that, and the reason that we stood up idea is to make sure that we're able to receive the information we need to then have the client and then the end device ultimately rasterize out the full light field based upon those agnostic parameters. So be it the field of view, the projection distance, all the other things from these otherwise completely flat planar surfaces. So that's my best shot at 90 seconds.
That was
There's a
very
lot of questions
succinct.
there.
Thank you.
Yeah.
So, but I wanted to leave everybody wanting to hear more. So what your call to action is, go to the website, sign up for the mailing list. If you sign up for the mailing list, you'll learn about our whole seminar that we'll be holding this fall, and you'll be able to dig deep and learn a lot more about it. If you're old school and don't want to use this interweb thing, you could also hand me a business card, and I'll add you to the list, but what the heck. And with that, we're out of time. Now, I think we'll hang around for a few minutes until they kick us out of the room. So thank you for coming, and if there's any other questions, please join us. And please join me in thanking our speakers today, teaching us about light fields and the metaverse. Have a good day.